Okay, we're looking at a region R that's in the first quadrant, and it's bounded below by y equals x squared and above by the lines y equals 20 minus x and y equals 17 plus 2x. I've gone ahead and I have sketched the region for you. The area where that I have highlighted in green, this area in here, is the region that we're looking at. Okay, now we want to find that area. Well, that area is kind of interesting because it needs to be broken up into two parts, because our upper boundary on one part of it is the curve, the y equals 17 plus 2x. So that's that one. That's the first region we need to deal with. And then we need to take care of the second region over here. And that one is instead bounded on the top by y equals 20 minus x. So I need to think about both parts of those. It's first going to be important for us to establish what's the breaking point, what's the intersection point here, so that I know how to take care of what my limit's going to be on each of the different integrals that I have to deal with. Okay, so a couple things that I need to establish that are, if I set the two lines equal to one another, so that's going to give me a point of intersection. And so if I subtract the 17, I'm going to have 3. If I add an x to both sides, I have 3x, and therefore x is 1. Okay. I'm going to also need to see what the value is here, so that I know where to stop the limit, the boundary on the second purple region. And that's the intersection of x squared and the line 20 minus x. So this is a quadratic, so for a quadratic I have to get everything set equal to 0. It's often advantageous to have the x squared positive. I can factor. So x is negative 5 or 4. So in our case, what we're working with is the 4. Now, to take care of those two integrals, I have to, in order to find the area between curves, you take the integral from their intersection points of the higher one minus the lower function. Okay, so in our first region there, our integral is going to go from 0 up to 1. The higher function is the one with the higher y values. So that's the 17 plus 2x. And then the lower boundary is the x squared. And then I am going to add to that the area of the second region, which in that case our boundaries are going to go from 1 to 4. I have to do my function with the higher y values. That's 20 minus x. and subtract off the x squared. I am going to leave it to you to do those computations. In my work, I came up with the final answer being 295 divided by 6, or 49 and 1/6. And that is the final area, or both.